This is our third lectures on previous year questions of ODE, ordinary differential equations. We have studied formulation of differential equations and the trajectories, self orthogonal like that, orthogonal trajectories and self orthogonal trajectories that also we have done. And today I'm going to take up two topics again. That is, one is variable separation method and the other one is linear differential equation. Okay, so I'll start with variable separation method. Variable separation. This method is not difficult at all. We just have to separate y and dy term and x dy or dx, I mean. So we just have to separate it and then integrate it. And also there is some special function if the function is in this form: ax plus by plus c equal to dy upon dx. Then you substitute this thing equal to v or anything z, any variable. Okay, let's start right away. This variable separation method. All right, this question is taken from 2011 10 marks question. Dy by dx. So like I said, let's substitute these things. Equal to v equal to 4x plus y plus 1. And what do we get if we differentiate dv with respect to x equal to x plus dy upon dx. What we need is dy by upon dx. dy ddx equal to dv dx minus x. So everything will be changed. Oh no, this is 4, right? 4, okay. So dv upon dx 4 plus dy upon dx. Dy upon dx will be okay. This is dv by dx. This equation 1 becomes dy dx minus 4 equal to v square. Okay, I'm going to separate this variable dx and dv. So we can do like this. dv, just think that it's like multiplying dx on every terms, no? So dv equal to v square plus 4 dx common, or dv upon v square plus 4 equal to dx. Let's integrate. We know that the integration of 1 upon x square plus a square dx equal to 1 by a tan inverse of x upon a. So we're going to apply this formula here. 1 by a, our a is 2, is tan inverse v upon 2 equal to x plus the constant of integrations. This 1 upon 2. Okay, if we transfer that two terms then to the other side, this will be 2x plus 2c. 2c1. So we say this is c1. Okay, c1. Or v equal to twice of tan 2x plus c, let's say, where our c is twice of c1. And our v, as we have substituted this term to be v, where's that? Okay, 4x plus y. 4x plus y plus 1 is equal to v. This is twice tan of 2x plus c. And there is an initial condition given, y of 0 equal to, this is same as f of 0 equal to 1. So our value of y is 1 when x is equal to 0. Let us substitute everything here. X is 0, y is 1. That means on the left hand side 2 will appear here. Y is 0 equal to 1. Okay, we are substituting here. It means 2 tan of c. This implies tan of c is 1. This implies C has to be pi by 4. That is 45 degree. No? Okay, we'll substitute everything in the first this equation. 4x plus y plus 1 equal to 2 tan of 2x plus pi by 4. So this is the answer. Giving particular value today, this is particular solution. Giving particular value to the constant. This is general equation. Okay, let's do the next question. The next question is, it's another variable separation method. First, I'll take up variable separation method. After that, linear differential equations. All right. Okay, let's do it. Here we go. The question is telling us to solve dy dx equal to 2xy ex upon y whole square divided by y square 1 plus ex by y whole square plus twice x square ex upon y whole square. This is 2012 questions which was asked for 12 marks. Okay, let's do it. Let's put let y by x by y equal to v. This implies x equal to vy, of course. So we're going to substitute everything, and dx, okay, let us differentiate with respect to y. Dx by dy equal to first function, okay, dy is gone, it's 1 only, and y dv upon dy. If we substitute here, this equation 1 becomes this is 1 upon dx by dy. So equation 1 implies 1 by v plus y dv by dy is equal to 2. Our x is vy, so this will appear vy square, and then e, and this is our v square. Okay, and then in the denominator y square 1 plus e v square plus 2v square y square, because x is vy, and then e v square. And we'll continue, we'll cross multiply. Okay, so this will be like this: y square 1 plus e v square plus 2v square y square e power v square equal to, let's multiply these things, 2v square y square e power v square plus the next term is 2vy cube, right? vy cube e v square dv upon dy. Let's look out for something common here. 2 square, okay, this is gone. Same term on different side with same sign. So, and furthermore, we can, since this is gone, we can cancel this term y, and then this also gone, and finally we get dv upon, oh sorry, oh, what's going on here? Where is that page? Come on. Yeah, this is the one. Okay, we'll continue. So 1 plus e v square upon twice v y e power v square equal to dv dy. Oh, the current has gone off. Oh god, it's too dark. Wait, okay. So we have to separate the variable, no? This y term is there. Okay, So 1 upon y dy. Okay, it's back. This is variable separation method. 2v e power v square 1 plus e v square dv. Okay, our favorite formula appears again. Last time also we have come across these things already. That is f dash x fx dx will give, this is log of f of x plus constant of integration, of course. So if we differentiate this term, it will appear like this, so this is twice v e v square dv. So let's integrate here. This is log of y already. So we substitute this as z dot equal to log of 1 plus e v square, and then plus log of c. This implies y is equal to log of y, rather log of 1 plus e v square into c. Cancel, and our y is 1 plus e v is x by y, right? X by y whole square into c. So this is the answer. Okay, the next question. Let me check out the question. Still we are doing the variable separation method already. Whether the question is here or not, let me check. I should have saved it. No, I don't see the question. So sorry. I think this you will be able to do it, y is a function of x such that the differential coefficient dy dx is equal to cos of x plus y plus sine of x plus y, and the question is asks us to find the relation between x and y, which is free from any derivative, or differential. Okay, so we need to eliminate those differential terms. 2013, 10 marks. Okay. Let's go ahead. Solution. It is given that dy dx is equal to sine of x plus y plus cos of x plus y. Let us substitute this x plus y as v. Let v equal to x plus y. Differentiate it with respect to x. dv with respect to x will give 1 plus dy by dx. So dy by dx will be dv by dx minus 1 equal to, this is sine of v plus cos of v, or dv by dx equal to cos of v plus, sine of v plus 1. We can separate the variable, all the v term, decide cos of v plus sine of v plus 1 equal to dx. So this is a standard integration. In this kind of problem, if we integrate, we use the trigonometrical identities. This is cos of 2x is, or 2v, let's say 1 minus tan square v by 1 plus tan square v. And sine of twice v is 1, twice tan of v divided by 1 minus tan square 1 plus. Because if there is minus here, this will be tan of twice v, okay? But in our case, it is plus, so this is the formula for sine of twice v. But what we have is v only, so this will appear v by 2, v by 2, v by 2, v by 2, and this is just v. So this is 1 minus tan square v by 2 divided by 1 plus tan square v by 2 plus 1, not 1, tan square v by 2, 1 plus tan square v by 2. In each and every problem, there are some steps which are very important, you know. So don't forget it. Like in this particular problem, this step is important. If we get stuck here, I don't think we will be able to reach as the answer. Okay, let us simplify here. 1 plus tan square v by 2. Then this is 1 minus tan square. Oh, sorry. Top v is there, right? Okay. Tan square v by 2 plus twice tan square v by 2 plus this thing will appear here, 1 plus tan square v by 2. Tan square v by 2 common here. This is gone. Then what do we get? dv by equal to dx is still there. 1 plus 1 is 2. Common 1 plus tan square v by 2, and then 1 plus tan square v by 2, another tan square v by 2. Wait. Twice tan square v by 2 still exists now. Okay, I'm taking out common here. Tan square v by 2 to okay, 1 plus tan square, 1 plus tan square v by 2 go to d of x. This is gone. If we integrate it, wait, okay, I'm missing out something. Why everything is gone? When I did it in the first place, it wasn't like this. Plus 1, right? This should be 1 plus tan square v by 2. This is 1 minus tan square by 2 by 2. Twice of tan v by 2. No, so sorry. This is v by 2. Okay, still correct only. I thought this is tan square. Be very careful. That's just tan v by 2. So I cannot cancel this one. Slight mistakes and we are doomed. Okay, we'll continue dv upon. Of course, we can take out 2 common here, but 1 plus this should be tan v by 2 only, not tan square v by 2. Tan square v. Let us bring up this one. This will be like sec square v by 2, right? Because 1 plus tan square theta is sec square theta plus tan formula. And let's just say x plus c. And what do we observe again? See, if we differentiate, we are getting this form again. F plus x, f of x, dx will be log of denominator. Because if we differentiate this denominator, this is sec square v by 2 and then 1 by 2. Right? So 1 by 2, this one. Okay, so we are going to get log of 1 plus tan of v by 2 equal to x plus c. And you substitute that value back, 1 plus tan of x plus y by 2 is equal to x plus c. So this is the answer. Since I have to do lots of problems, I'll go a bit faster, okay? Now the last problem on variable separation, and then we will proceed to linear differential equations. So the question is, I think I have copied this question. Let's search for it. Bacteria problem. Okay, where did I paste it? Okay, it appears here. You can read the question. Okay, let's do it. If the growth rate of the population of bacteria at any time t is proportional, okay, growth rate means x, proportional to the amount present at that time. let x be the amount of present at the time. That means rate of change dx by dt. The growth rate of population vector any time t is proportional to the amount present, that is x. Okay, that means dx quantity, if we put a constant of integration, this is kx. And given that if t is at in 1 week, no? 1 week population gets doubled. Let's say initial 1 week is x naught, then in 1 week this will be 2x naught, and we are going to find this one. Then x is what? This is what the question is asking. What is the expected population of bacteria? All right, yeah, this is simple thing. We'll separate the variable dx by x equal to k dt. Integrate, this will be log of x equal to kt plus constant of integration. This is x e power kt plus c. Okay, and let's use the given condition. At time 0 is, of course, initially it was x naught. And also this can be further simplified as et e power c. Let's e power c is a, let's say, since it is a constant, no? Is a is ec or log of a equal to c. This would be when t is 0, no? T is 0, then this is same as a also. When t is 1, x equal to 2 of x naught. This is what? A, or a is x naught already, x naught e power k, right? Because t is 1 in this case. So cancel, this is e power k equal to 2. That means log of e equal to log. See, if we take log, then our k is equal to log of t, because log of e power x is x. I think we have done this already. We're almost there. Since we have known this, okay, when t is equal to 4, let's say, at any time t, this is the formula, no? At any time t, so x equal to x naught e power k times of, when t is 4, this will be t is 4, no? Okay, and our k is also log 2, so x by x naught e to the power 4 log of 2, and this can be written as e log of 2 power 4. 2 power 4 is 2 power cube into 2, that is 8 into 2 is 16. So e power x something is that this formula again. This is 2 power 4, which is equal to 16. This implies that x is equal to 16 times of the initial one. This is the initial amount of bacteria, and after 4 weeks, it is expected to be 16 times of the initial. Okay. Let's proceed to the next question. Okay, variable separation is done. Let us now go to linear differential equations. Linear differential equations, let's do it. This is possible. Okay, simple problem here. This one, I think. Yeah, it's 2010 questions, 12 marks. dy by dx plus py equal to q. This p and q are functions of x. How do we get this solution? This integrating factor is e to the power p dx, and then the solution y would be equal to y into I into f is equal to integrating factor q dx plus c. This is how we solve linear differential equations. We are going to use this same thing here. And of course, if the dy dx plus py equal to this 0, then this is called homogeneous equations. This y can be x also, I think. So y dash equal to alpha x we have in this form. This is dy by dx. Let's separate the variable x dx, right? Then what do we get here? Wait. Dy by dx. Okay. Yeah, we can do like this also. No. This is standard form. Now we cannot follow any order. This is dy by dx minus alpha x equal to 0. In this case, we will find the integrating factor. This is equal to e power this coefficient, this p. Our p is alpha only. Minus alpha rather, dx. This can be confusing, okay? In this case, y is equal to x, that's why. And there is another standard form also, dx by dy plus p of x equal to q also is there. But don't get confused with this one. I was confused, before while I was solving this problem. Minus alpha x. So since we know the integrating factor, the solution is y times of e power integrating factor equal to integrating factor, and then times what is our q? Our q is, like I said, minus alpha. Oh no, our q is 0, no? This homogeneous equation. And dx plus constant of integration. This is y. This has gone to be 0. This e alpha x. So this is the solutions. Or y e power minus alpha x. Let's just keep like this. Since in this given questions, see, this is the general solution. No? Suppose alpha is also any solution. Phi x is any solution. Then what do we get? Phi x e power minus alpha x is equal to psi x. This is what is given in the question. But since this is a solution, this should be equal to c. Therefore, psi of x is a constant function. Okay, phi x is an solution, then okay, this part we have proof. And if alpha is less than 0, and then every solution tends to 0 as x tends to 0. X tends to infinity. Infinity, y tends to 0. Whether this condition satisfies or not, let's see. Our solution is y e power minus alpha x equal to c. This implies y is a solution, some constant divided by e power alpha x. Okay, since alpha is negative, 2 e is 2 point something, and then this is in the denominator, okay, and alpha is negative, right? That means alpha is, let's say, if alpha is minus 1, then this will be e, then e power minus x be 1 by 2, right? 1 by 2 something, that is very small. But if alpha is, let's say, okay, let's alpha is minus 1, and then x is tending to infinity, no? Let's consider something very big here, 500, let's say. Then this will be appear as 1 by 2 power 500. This is almost equal to 0, no? Tending towards 0. So when alpha is less than 0, x tends to infinity, then alpha x is very small. Of course, alpha x per se, this is very big. It's this is a very big number. This is tending towards infinity. So something upon 1 by e power minus infinity would be, this is not alpha, okay, infinity. I cannot differentiate infinity. Should be very small. Because 2 point something something, that's the meaning. Negative 1. Okay, x tends to infinity. Yup, this is a very big number, but this is negative, so c by this e power, a very big number, no? Big number, then this is tending to 0. Okay, let's stop discussing. I hope you understood it completely. So there will be some twist in the questions, okay? We should not be surprising to see these kind of questions. Instead, we should handle it coolly, you know. Of course, without much practice, if we find the problem to be a little bit twisted, we get nervous also, we got tense in the exams. Okay, 2.1 problem is done. Now I will go to next linear differential equations. We have still 3 more questions to be solved, okay? Okay, now another one. This question is a little bit incomplete, you know, so I added here W. Yeah. Okay, let's go ahead. Our given equation is y prime plus px y equal to 0. This is also of the form dy by dx plus px y equal to qx, where qx is equal to 0. This is a homogeneous equations. Our integrating factor would be equal to e power px dx. And so the solution is y e power p dx. I'll just write p, okay? Dx equal to, our q is 0, dx equal to, this thing will go to 0, 0 plus c, right? Equal to c. Okay, so our solution is c e power minus p dx. This is the solution. Set of solution homogeneous differential equation. Okay, this on an interval AB forms a vector space, subspace of continuous function on I. Okay, there is a function called set of functions, you know, f, and then this is a continuous function, a real valued continuous function, and of course this is a vector space, you know. This is a vector space on already. From here we are taking out some functions such that those functions will satisfy this condition px y equal to 0, and those values which satisfy this condition can form a set. This is a set such that this is c e power minus p dx. So this is a solution set, and we need to show that this is a subspace of, let's say this is V, vector space. And in order to show that this is a subspace, what we need to do is take 2 elements from here, y1, y2, and of course these values, these are in W, and we need to show that for any 2 real numbers, alpha and beta, alpha y plus, this linear combination also needs to be in W. Okay, whether we are in the position to show that this linear combination is in W or not. All right, let's proceed. For let y1, y2 belongs to W, this solution set, okay? Our solution set is this one. Then what? Since it is in solution set, it should satisfy that condition. y1 is equal to 0 and y2 prime plus px y2 is also equal to 0. Okay, now let us find the linear combination alpha y1 plus beta y2 dash, okay, plus px, and then our y is alpha y1 plus beta y2 equal to, we don't know this is 0 or not, okay. If this is 0, then alpha y1 plus beta y2 is also a solution, so we need to show that this is a solution, you know, then our job is done. So this should give 0. From differentiation, this is y prime plus by2 prime plus px alpha y1 plus px beta y2. Let us combine the alpha term, alpha, then y dash plus px y1 plus beta term y2 prime plus beta y, wait, beta is taken out, px, and this is y2. Yeah, this, from these two equations we have shown that this is 0. So alpha into 0 plus beta into 0. Any real number into 0 is 0 plus 0. Okay, this is 0. Since this is 0, this is also a solution. So W is a vector space. This much we know. If this is a vector space, then what is left for us to solve? Okay, what is the dimension? Okay, dimension. Dimension means, dimension of vector space is the number of basis elements. That's the definition of dimension. Let me give you a very simple example. On x-axis, let's say 0. Any value on this number line can be represented by a vector, let's say x, 0, no, it should be 1, 0, okay, can be represented because y coordinates is 0, y is 0, since it is on horizontal axis, x is 1, so this is a vector. To this vector, so this dimension of this r is 1 because it can be formed by this single vector. Let's say let's denote 5 on this number line, then you just have to multiply with that vector 1, 0, this is equal to 5, 0. So this so by using only this single vector, 1, 0, we can find this one, any point on this number line. Likewise, this solution space also can be found out by single vector, that is this one, e power minus p dx. See, we took y1, y2 also. This y1 can be written as something like c1 e power minus p dx, and y2 can be written as c2 e power minus p dx. So this single vector is playing the role of basis. Therefore, dimension of W equal to 1. Okay, this much I can tell you, since it is not a linear algebra class. Don't worry, if you still got a doubt, you can learn from linear algebra again. Okay, we have done this problem. Linear algebra is all about solving solutions. So, and differential equations also related with solutions. That's why these linear combinations and linear algebra stuff's also coming into play. Okay, as I've told you, I'll be solving 3 more questions. One is down again. We are left with just 2 questions. Let's delete. Homogeneous subspace. No, it's not here anymore. I need to look from the book again. 2.17. Acha, let's solve this again. Solve dy dx equal to 1 by 1 plus x square e power tan inverse x minus y. Okay. You have to keep this thing in mind, plus p x dy equal to q of x. This is a standard linear differential equation, so let's arrange in that standard form. This should be plus 1 by 1 plus x square y equal to, this thing remains tan inverse of x 1 plus x squared. This is our q, this is our p. So integrating factor is e power 1 by 1 plus x squared d of x. This is e power tan inverse of x. So solution is y into integrating factor tan inverse of x is equal to e tan inverse of x, and our q is tan inverse of x divided by 1 plus x squared d of x. Everywhere tan inverse x. Okay, let tan inverse of x equal to t. So if we differentiate it, this will be 1 by 1 plus x squared dx equal to d of t. So this equation, let's say A. Equation A becomes, I'm writing it very fast, okay? Guys, if we don't do like this also, we have got lots of problems to solve. This is just the starting part. Right? These are just a simple problem. T, and then this 1 by 1 plus x squared dx is dt. Okay. YET, this part no integration. Okay, this is e power 2t is e power 2t only, and then we should divide it by this. Am I right? E power 2t, yeah. And y is equal to 1 upon 2 e power t, right? This and this. 1 by 2 e power, okay, plus constant of integration also has to be there, e power minus t. So this is e power tan inverse of x plus c e power minus tan inverse of x. So this is the solution. Okay, well, we are left with one final problem. It's an easy problem again. I think you can do this one. Solve y1 minus x tan of x plus x squared cos of x dx minus x dy equal to 0. This is 2016, 10 marks. The previous one was asked in 2016, that also 10 marks. Just amazing. If you know this linear differential equations, you can score 20 marks easily in 2016. Okay, I want you to try this problem. This is also linear differential equations. You also know you transfer the terms here and there. All the best to you.